We go. Good morning and welcome to AP Stats. We're going over the homework, the assignment from page 40. And just a little bit of feedback for you. First of all, on problem 28, part E, when they said, what are the conditional distributions of origin by driver classification? That's a condensed, more compact way of asking the question, what is the distribution of conditional relative frequencies of origin for every category of driver classification? So you would have had to have a distribution. Oh, and by the way, it didn't say conditional relative frequency, but that's implied. So when you did those, did you do distributions of percentages? Well, in part E, when they're asking for essentially the distribution of conditional relative frequencies of origin for every category of driver classification, the driver classifications there were two categories. Student was one and staff was the other. So the basic structure of what that should have looked like on the homework for part E was there should have been a distribution for student, and there should have been another distribution for staff. It should have been a distribution of conditional relative frequencies of origin. Could have been either American, European, or Asian. First the student distribution, then the staff distribution. So instead of distribution of conditional relative frequency of the variable class for every category of survival, is this. So that means that you had to have 6 numbers. And I'm just curious, it looks like, okay, this student wrote, and they would all have to add up to 100%. Both of the distributions would have to add up to 100%. So this student looks like he did a good job because he said it was 50 for students. The student wrote for student, it's American 55%, European 17%, and Asian 28%. The student had it written out in sentence form, not like this, but full credit on that for that distribution. But then this student wrote on his homework that for staff, it was American 64%, European 7%, and Asian 29%. Out of curiosity, how many of you remember doing letter E something like this? This is like the basic approach that you took to letter E. Okay, so for several of you, you did. If you didn't do it, that's what I was looking for. That's what I'm looking for in the homework. Now, first time through the homework, I tend to be fairly lenient in grading the homework. So if this like blew past you and you did not see the connection between the Titanic problem, the work we've been doing in class, and this homework problem, that's okay. You have until the quiz to get this concept done. Okay, so do you have any questions as to how it is that you could have possibly come up with your answer to part E as being, for students, it was 55% American, 70% European, and 28% Asian. And for staff, it was 64% American, 7% European, 29% Asian. Question, yes, go ahead.
What I did is like, I thought it's American as 100%. How many percent is students? How many percent
Yeah,
is
some people interpreted that instead of going up and down, they want to cross.
Yes.
So that's why it comes down to the wording of the question.
Yes.
The wording of the question was, what are the conditional distributions, which is a compact way of saying the distribution of conditional relative frequencies. Distribution of conditional relative frequencies, that's 5 words compacted into 2 words, which was conditional distributions of origin by driver classification. So basically, what is the distribution of origin for every category of driver classification? So they didn't word it exactly like that, but I'm just basically explaining now how to interpret the wording that was in the homework. You didn't get it when you did the homework, that's okay. I'm not going to take off a lot of points, okay? First time, we're just getting used to it. So that's okay. So, but yeah, that's correct interpretation. Yes, go ahead.
So how can you say, if the question was
Wanted the other way, how would it have been worded?
Yeah.
Yeah, they would have said, what are the conditional distributions of driver by country of origin? What's the distribution of driver, basically distributing to student and staff by country of origin, which means for each category of country of origin. So what was the distribution of driver for Americans? Oh, it was, a certain percent students, certain percent staff. Those two numbers would have added up to 100%. What's the distribution of driver for the category of European cars? Well, there it's blank percent student, blank percent staff. So if you want an approach to interpretation here, it's whatever word comes after the word by is basically the variable for which you want various categories.
After
It's whatever comes after the word by in the author's way of describing these problems. So yeah, that's, believe me.
So this is by the driver, right?
Yeah, this one is the distribution of conditional relative frequencies of country of origin by driver classification. So, okay. Believe me, the first time I taught AP Stats, when I got to problem 28 part E, I was like, wait a second, what are they asking? And it took me a while to take their compact language and understand it in terms of the language that we were using in class. Okay, so that's one issue I know comes up on the homework. A second issue on the homework is part F. Do you think that origin of car is independent of the type of driver? Well, what we learned in class last week was that two variables are independent if the distribution of conditional relative frequencies of country of origin is the same for all categories of driver. Are these two distributions the same? No, we wouldn't expect them to be exactly the same, but they're not even close. So if we're going to write about this, which comparison is most, gives us the best opportunity for clickbait? Would it be the comparison at the American level, the European level, or the Asian level?
European.
Yeah, it's certainly not the Asian level. They're pretty close. It's the European level. So here's what I would expect you to say. In part F on the homework, because they asked you to explain why, you would say origin is not independent of driver because the distribution of conditional relative frequencies of origin is not the same for all categories of driver. By the way, that was exactly the wording for this student whose paper happened to be right on the top. Now I'm going to continue reading this example from student homework that was turned in minutes ago. For example, 17% of students have a European car, and only 7% of staff have a European car. Had origin been independent of driver, these two conditional relative frequencies would have been similar to the relative frequency of having a European car, which was 13%. Wow, that's an E+. That's fantastic. Now, this happens to be a student who went the other way in part E, who ended up going across, but then they went back and they did these calculations for part F. So this student misinterpreted part E a little bit, but that's okay. We're still learning how to interpret that. So anyway, 3 sentences, just like those 3 sentences that we learned in class last week. Do you have any follow-up questions on the homework in terms of, what sorts of challenges you encountered? Alrighty. Would you please take out for one last time the Titanic handout? There's just a couple of loose ends we want to tie up there from what we're doing at the end of class, and then we're going to move on. I'm going to hit pause on the camera for a second until we make this transition. So we'll be right back. Welcome back. Just a quick heads up about the homework. The homework that was due today was very unique. It was from the textbook. All the other homework assignments for the rest of the year are going to be not from the textbook. They're going to be from handouts that you do on a separate sheet of paper. So here's the handout for the rest of the Unit 1 homework. All right, so those of you who are absent today, make sure that you recognize that this handout is on the website. Let's take a look at where it is. In case you ever lose this sheet of paper that I just handed out to the people who are present today, you can go to Topics and Unit 1. And notice that in Unit 1, we have the assignment sheet, which I just handed out a paper copy, but it's graded for accuracy. See, 40/28 solutions. Ooh, how many of you noticed the solutions were there? Solutions to the homework due today were online. Whoa, what was up with that? I don't know if they're worded quite as well as that one student did, but there's also a PowerPoint here, and this is optional. This is one way to get at the curriculum, is to look at the PowerPoint for this first unit. PowerPoint presentation, you can study that. The mega packet is like a whole bunch of problems that you can do to practice for the test, and the solutions to the mega packet are there. It's like a review sheet for Unit 1. It's optional. But if you're thinking, man, I want to be prepared for the Unit 1 test, which I believe syllabus it's going to be at the end of next week, not this week, but at the end of next week is the Unit 1 test. You might want to start working through a few of these mega packet problems to make sure that you're reviewing. Don't wait until the night before the test to review. You can do some review. It's optional, but it's a college level course. Here, this is AP. This is an AP course. So we provide you with resources, but you don't have to use every resource. The homeworks are short. If you look at this assignment sheet, you see that there's assignment 1.3. We did 1.1, there is no 1.2. So assignment 1.3 is just this one problem, parts A, B, and C. And I'm expecting that assignment 1.3 will be due on block day. And then assignment 1.4 is the only other homework. So in terms of required homework, which is turned in on paper, on a separate sheet of paper, there's only 2 more homework assignments this entire unit. And it's all right here in front of you. It's graded for accuracy. Complete sentences. It is a writing course. Now, as far as the due dates for these, just so you know, you may as well make a note right now as to when these assignments are due. Take a look at.
Can I put it in my phone?
Sure. Yeah, that's fine. Thanks for asking. 1819, one assignments. And the syllabus. I don't know if it's posted online yet, but for tonight, the homework is to read chapter 4 of the book. 1.3, which is on the sheet of paper in front of you, is due on Wednesday of this week. It's due on block day. And 1.4, which is the only other homework assignment to this unit, is due the next block day. So it looks like, bottom line is that there's about 1 homework assignment due per week in this first unit. All right, so that just gives you a picture of what's going on. The Unit 1 test looks like it's going to be Friday, September 7th. So we're just getting some business items here out of the way, letting you know what the homework is. Do you have any follow-up questions as to what's going on for Unit 1 in terms of homework? So that's it. I haven't planned out all the details of Unit 2 yet, but all right, take a practice test next week on block day. So that is the plan for homework. So Summit 1.3 due on Wednesday. Now, I had asked you to take out the Titanic handout again. And I believe I have the Titanic handout right here, ready to look at with you. And if you recall, at the end of last week, we had made it to the specifications for how to make a memorial to those who died on the maiden voyage of the Titanic. And I disclosed to you that I had driven to Belfast, Northern Ireland with my family, and we actually walked on the sidewalks between the regions of the Titanic Memorial. That was inspired by this distribution on the previous page. They took this distribution of conditional relative frequencies of class for the category of survival called dead. And they said, we want 8% of the grassy area to memorialize the first class passengers, 11% of the grassy area for second class, 35% of that huge grassy area, which was like a bird's eye view of the outline of the Titanic, was for third class passengers. That was very moving. It's a huge area for the people who apparently were more likely to not have that much money. And then 45% of that grassy area was for the crew. And I asked you at the end of class on Friday to write out what would the segmented bar chart have looked like had survival been independent of class. And then the bell rang. We just couldn't quite finish going over that, except for the fact that I did mention that if you thought it was 25% green, 25% purple, 25% blue, 25% orange, that's a common mistake, but it's not correct. The correct answer would have been, and this is why I'd like to work with you now, just to wrap up this problem, should have been based on the specifications that we see here in the marginal distribution of class for every category of, for every category of class's marginal distribution was 15% first class. So let's take 15, 13, 32, 40 to this segmented bar chart. Key numbers are 15, I've got to see it again, 15, 13, 32, 40. 15, 13, 32, 40. So let's do it together. Let's start with the 40 on the bottom. Let's start with the crew. It would have been, had survival in class been independent, then we would have had 40% of the alive were crew members, and 40% of the dead are crew members. And if you're taking notes not in color, but rather using this legend, which we had started on Friday, instead of orange, you would be using vertical slashes there to represent crew. Now, an additional 30% would be for third class. I'm going to switch over to blue. 32%. So to 40, I'm going to add 32 to take me up to 72, 50, 60, 72. So this would have been the section for third class. Had survival been independent of class, we would have expected 32% of the alive, of the living, to be third class, and 32% of the dead to be third class. Next, switching to purple. This is second class, 13% on both. So we're going from 72, adding 13 to 72 gives me 85. So it would have been 85% up to 85%. So this 13% of the living would have been second class, 13% of the dead would have been second class, and then the rest was first class. It would have been only 15% of the living would have been alive, and only 15% of the dead would have been alive. I mean, it just sounds right. I mean, if 15% of the overall passengers were first class, then if survival had nothing to do with class, then you would expect 15% of the living to be first class, 15% of the dead to be first class. This is what it would have looked like had survival been independent of class. And these would have been the specifications. You can still memorialize the dead and make it big enough to be visible from the Google satellite, but it just would have looked a lot different than it actually did look. And so now we're learning, how can you tell? Well, I mean, what's the most vivid clickbait? What's going to generate the most clickbait? Talking about the orange comparison, the blue, the purple, or the green.
Orange.
Yeah, orange is noticeable,
Those two, the green.
but clearly the green one is the one that's really going to raise eyebrows. Well, among the dead, and the numbers for it were on this previous problem. Among the dead, only 8% of the dead were first class, but 29% of the living were first class. Had survival been independent of class, then those two numbers would have been the same. First sentence, based on looking at the segmented bar chart, is that survival, which is really this variable down here, survival is not independent of class. Why? Well, look, only 8% of the dead were first class passengers, but 29% of the living were first class passengers. Had survival been independent of class, then those two numbers would have been the same. Those two areas would have been the same. Those two green sections would have been the same. So, just wanted to bring that one to closure. We didn't quite bring it to closure last week. Do you have any follow-up questions on the segmented bar charts problem? So that's as far as we're going with that. On the back side of this handout, is there a blank on the back? No, okay. So I have a new handout for you. And this handout is to prepare you for assignment 1.3, which is due on Wednesday. Now, please forgive me for speaking so loudly, but I'm aware that I'm not wearing a mic and that I've got to somehow get my voice onto this video recording. So here we go. Today's handout, I'm going to ask you to turn to the blank side of this handout. And you happen to know that you're going to see anyone who's absent today, any of the 6 people who are absent, and maybe they're hoping that you'll bring them a copy of the handout. I'm just going to put the extras right here in case you want to take one for a missing group member or something like that. So, on the blank side of the handout that I just gave you, let's take a look at the lesson for today. So, your handout probably looks something like, it has the sugar in cereals on one side. On the blank side, I'd like to talk to you about ways in which you can describe a distribution. So let's label these notes 1.3 because they're designed to prepare you for assignment 1.3, which is due on Wednesday. Here we go. The title of the lesson is Describing Distributions. And the mantra, if you will, that I'd like you to come away with is shape, center, spread, and unusual features. When you're describing a distribution, and they will at least once on the AP test give you a distribution in the form of a histogram and ask you to describe it, what they're really asking for is the shape of the distribution, shape, center, and spread. What's the shape of the distribution? What's the center? What's the spread? And also, what are the unusual features? Okay, so shape, center, spread, and unusual features. When I say go, I'd like you to just out loud and in unison, would you please just repeat the mantra for describing distributions. When I say go, I'd like you to say shape, center, spread, and unusual features. Ready? Have at it. Go. Shape, center, spread, and unusual features. That's it. Those are the 4 categories that they'd like you to write about when you look at a distribution. Oh, by the way, if you want, you can take a look at the distribution of cereals. This is, they'll say something like, describe the distribution. By the way, what this means is that when you look at the description, it says it's a histogram that displays the sugar content as percent of weight of 49 brands of cereals. So someone sampled 49 different cereals. I mean, there's probably like 300 or 400 brands of breakfast cereals, and like there's, back when I was a kid, they had this, I mean, they had Captain Crunch when I was a kid. How many of you have ever tried Captain Crunch cereal? Anyone here? Captain Crunch? Lots of sugar, let me tell you, if you've never tried it. It's probably not the best thing for you. Probably not the best thing for your teeth. But they also had this cereal called Quisp. Quisp was my favorite as a kid. Quisp was an alien, Q-U-I-S-P, and this little pieces of cereal were shaped like flying saucers. I loved not only eating Quisp cereal, but thinking about what it would be like to fly on one of those flying saucers to a distant region or corner of the galaxy. Quisp was probably one of these cereals like way up. It was probably, you know, somewhere between 52 and 56% sugar. So notice the bars in the histogram are all touching each other, and 0 to 4 grams. So it's like including 0 up to, but not including 4. So there were, you can tell there were 6 brands of cereal. Quisp was not one of them. That had somewhere between 0 and 4%. That's that first bar. It's including 0, but not including 4. And there were, it's like there's 6 cereals. I'll do tallies, 1, 2, 3, 4, 5, 6. So that's why it's going up to 6. Now, if a cereal has exactly 4% sugar, then it would go into the second bin. The second bin was anywhere from 4 up to 8. So 4 up to 8, but not including 8. And there were apparently, when they counted up, of the 49 cereals, 8 of them, I'm going to just go and put a little 8 above this bar to indicate, okay, there are 8 cereals that fit into this bin of the histogram. And the reason I'm drawing them again up here is to just show you what to do with the boundaries. If a cereal has exactly 4% sugar, you put it in the bin to the right. If it's on the boundary, put it into the bin to the right. So anyway, there were 1, 2, 3, 4, 5, 6, 7, 8 cereals that fell into this bin, and it goes on up. So this is an example of a distribution that you'd be expected to describe its shape, center, spread, and unusual features. So keep this example in your mind as we go through the vocabulary that you're going to be expected to use. So here we go. I think I accidentally put in a whole bunch of pages that I didn't want. I'm just deleting those right now. Here we go. This is where I want to be. So words that you're going to use for shape are going to be words like unimodal. A mode is like a hump. There's just like one hump in the graph. It could be bimodal. Our serial distribution is bimodal. Sometimes you'll look at a distribution in the form of a histogram, and there'll be maybe like 3 humps in there. We would call it trimodal. Usually they're unimodal and symmetric, but you know, sometimes bimodal, trimodal, might say multimodal. Could be uniform. You often will get a uniform distribution. So you need 2 words for shape. The first word is going to be selected from these 5. It's going to be either, you know, I think pretty much all the distributions you see will be either unimodal, bimodal, trimodal, multimodal, or uniform. By the way, a uniform distribution is a sort of thing that, you know, just imagine that you had 49 cereals. uniformly distributed. Maybe it'd be like 7, 7, 3, 4, 5, 6, 7. Suppose there were 7 cereals in the 0 to 4 range, 7 cereals in the 4 to 8, 8 to 12, 16, 20, 24, 28. What if there is, that's what a uniform distribution looks like. No humps. It's just the same in every bar of the histogram, the same number of tally marks in every bar. That's an example of a distribution that's nearly uniform. Okay, so the other word you need to describe shape, first one is one of those 5. The second word when describing shape is going to be something like symmetric, skewed right, or skewed left. So, symmetric, skewed right is on the blank side, or skewed left. So you look at a histogram, to describe the shape, you'll have to pick this. Now, as you take a look at these 3 options, I just want to give you a basic idea of what we mean by symmetric, a visual idea. By symmetric, and I'm going to move these words over just a little bit so I can fit some shapes in here. If a graph is unimodal and symmetric, then it's going to look like a bell curve. And again, these are like, this line shows where the tops of the bars of the histogram are, or the bins. So if you had a histogram where they get taller, I'm drawing bars or bins that are taller and taller, and then they get shorter and shorter, and it's like a bell-shaped curve. That's unimodal and symmetric. Suppose a line that goes through the top of every bin is not symmetric, but shaped like this. It has what's called a tail on the right of the distribution. It's not symmetric, it's what we call skewed right. If the tail is on the right, then the distribution is skewed right. This one is unimodal and skewed right. Here's an example of a distribution that has only one hump, so it's unimodal, but it's got a tail on the left. We would call the shape of this, we would describe the shape of this distribution as unimodal and skewed left. So, there's more to be said about what specifically is the difference between symmetric and skewed, but just in terms of vocabulary, that's what we have to choose from. Yes, question, go ahead.
Short and tall, short and tall, short, short and tall. Like, what if it's random? You would say it's multimodal, but which
way is it skewed?
Yeah.
Yeah. So, there is a precise definition of skewed that has to do with the upper 50% of the data and the lower 50% of the data. And since you've asked the question so directly, that's an indication to me that you are ready to hear the answer to your question. So what we do is we look at what's called the spread of the upper 50% and the lower 50%. Suppose the upper or the lower 50% of the cereal, and suppose it has that like random, up, down, multimodal approach. So for 49 cereals, half of that is about 25. It's like 24, 25. So suppose we take a look at the lower 25 cereals. Suppose it were exactly 50 cereals. And suppose the lower 50% of the distribution, 50% of the cereals went from 0% sugar up to, say, something crazy like 40% sugar. This is the bottom 50% of the distribution. And suppose the top 50% of the distribution went from 40% sugar up to 70% sugar. So I have percentages all over the place. But so this is the lower 50% of the cereals go from 0 to 40. And the top 50% of the cereals, and remember, let's say there's 50 cereals. So there's 25 cereals that go from 0 to 40%. And the other 25 cereals, the sugary half goes from 40 to 70. So if the bottom 50% is more spread out than the top 50%, which is the case here, then it's skewed left. Skewed left means that the bottom 50% is more spread out than the top 50%. Skewed right means that the top 50% would be more spread out than the bottom 50%. So that's the answer has a precise numerical definition that you can rely on to tell objectively whether the distribution is skewed left or skewed right. We're going to work more with that, but that is the answer to your question. You just break the distribution in half and look at how spread out it is. So we'll get more into that with spread, shape, center, and spread. Now, when you're talking about the center of a distribution, you can talk about either the mean of the distribution, which is add them all up and divide by the total number, just the average, or the median. Now, it depends on whether it's skewed left or skewed right. You would only want to use the mean when the distribution is symmetric. If the distribution is skewed, right, S-K-E-W, if it's skewed, then you would want to use the median as your measure of center, because means are very sensitive to tails, like extreme values that are like way up here. That if there's a value, like, let's say people are getting, like 80% on the test, and, it's spread out a little bit. But then you got one person way down here who got a 10% on the test. That number is going to skew means to pull. That number is going to pull the mean down. The mean is going to go way down. The median won't move very much. The median is the middle value. The middle value will sometimes be a much better indicator of center in a skewed distribution. This lesson finishes tomorrow. The homework on this is not due till Wednesday. So we're just going to pick up here where we left off. You are dismissed. No homework due tomorrow. All I ask is that you read chapter 4. You are dismissed.